Welcome everyone. This is going to be our first lesson for pre-calculus. This is going to go over our first section, which is mostly review, so we're going to kind of speed through it. A lot of this you can probably just go through quickly. It's not a lot of new material, but it is material that's important we know before we proceed into new pre-calculus material. Okay, let's get started. All right, so we're taking a look at chapter 2, section 1 of our book, so you can follow along there if you want to. This one is looking kind of like at functions and some properties of functions. So first, we should know what a relation is. A relation is just a correspondence between x and y. Between x and y, two variables x and y. And there's not a lot of rules for a relation like there are with functions. So a function is a type of relation. You might have seen function defined in earlier classes as a relation where every input has only one output. So for each x, there's only one corresponding y. Our book defines it similarly, just using a little bit of some different language. Our book is using two sets of numbers, x and y, are two different sets of numbers. A function from x into y is a relation that associates each element, so element is just number, of x with a unique element of y. And so here the key word is unique. Unique means that there's only one element of y that is corresponding to each element of x. So the same kind of wording that we see up here in previous classes, just a little bit more complicated using unique, a little bit more formal, you could say. The domain of a function is the set of x using this definition. And one thing to note is the domain is only numbers or elements in x that the function can input and then give you an output. For example, if we're looking at the function square root of x, in this case positive square root of x, if we're considering only the reals, then our domain in this case is only going to be x in the set of reals. So this just means in the set of, or it's a part of real numbers, such that x is going to be non-negative. So that means it's greater than or equal to 0. So just some notation there. Our domain is only non-negative numbers. So it's not, even though it's part of negative numbers are part of the real number set, they're not in the domain of this function. Similarly, the range is just the set of y, or set of images of x in y. So all of the corresponding values from x into y. So if we're still looking at square root of x, positive square root of x, range is going to be the exact same thing. Y is where y is again non-negative. The only outputs we have are 0 and positive numbers. Okay, moving on. So we looked at the definition of a function. Next up, just some notation. So of course, we should be familiar with f of x, function of x. X is the input, and then f is the output. Sometimes we'll say the value of f at x, use a little bit of different wording. But this just specifies what our input is, and then it's an easy way to differentiate different functions, especially if we have multiple that we're talking about. Independent, dependent variables. So x is our independent variable, and our dependent variable is the output, or f of x, because it depends or changes depending on what you put into our function. And then finally, x is also called sometimes the argument. So just some wording that you might not have seen before. X is the argument of the function. So if you ever see argument of a function, it means the input or the x value. Okay, moving on, we'll talk a little bit about testing for a function. So for testing to see if we have a function or just a relation, we can first look at if we have a table or set of points. We just need to make sure that each x has one unique y value. So if we have a set of points, 1, 2, 2, 4, and 1, 3. So here clearly we do not have a function because our input of 1 corresponds with 2 different y values or 2 different outputs. One thing to note is the opposite can be true and it can still be a function. So you can have a y that corresponds with more than one x. A quick example of this would be if we looked at x squared. So parabola here, if we look at the y value of 4, 4 corresponds with both 2 and -2 for our x values, and it's still a function. So we're just looking in one direction. Each x has one unique y. And of course, if we have a graph, we can use our vertical line test. So here, if we have a vertical line and we move it left or right, it will never pass through the function twice. If a vertical line passes through the graph twice at any point, then it's not a function. An example of a non-function that we can identify using the vertical line test is the positive and negative square root of x. So here we have a sideways parabola, and of course it doesn't pass the vertical line test because we pass through our function more than once at many points, at least one point. Okay, so those are a couple of tests we can do to quickly identify if we're dealing with a function. Functions are important because we have a lot of tools that we can use with functions that won't necessarily work for non-functions. So it is important that we know what a function is, how to identify it, so that we can then look at our toolkit of tools that we can use with functions. Okay. Finally, for the domain of a function, sometimes we'll be asked to identify the domain given an equation. And for identifying the domain, we just want to see, so to identify, we just want to see what values of x result in a undefined output. So find values of x or input that result in an undefined output. So our textbook has a few examples. First, they look at f of x equals x squared plus 5x. Okay, so here we have a quadratic. If we graph this, we end up with a parabola. And there are no values of x where if we plug it in, some issue is going to happen or we'll have an undefined value. So our domain here is all values of x in reals, and that's it. There's no specifications we have to make because any value of x gives us a defined output. An example where the domain would be restricted is g of x equals 3x over x squared minus 4. So in this case, we're looking at dividing by 0. We know if we divide by 0, then we get an undefined value of y. That means we want to look at the denominator of this function, x squared minus 4, and identify which values of x give us 0 for that. So of course, you can solve this a few different ways. It's quadratic. I'm choosing to just factor it and then use the zero product property. So x cannot equal 2 and x cannot equal -2. So one way to write this domain, we have our domain, x values belonging to the real number set, such that x is not equal to 2 or -2. So I'm right on the edge there. Sorry. There we go. So x does not equal 2, and then I have a comma -2, and we would end that with a closed curly bracket. Okay, so our domain is restricted. There are 2 values of x that give us an undefined value of y. Finally, our last function that our book gives us as an example is h of t equals the square root of 4 minus 3t. Okay, so here we're looking at a root. We know that if we take a root of a negative number, then we get an undefined output, at least when we're working in the real number set. So here we're looking at what values of t will give us a negative number, 4 minus 3t. when does this give us a number less than 0? So we can solve this really quickly. Negative 3t is less than negative 4. So t is greater than positive 4/3. So anything greater than 4/3 gives us an undefined h of t value or output. So for this domain, we're looking at all values of t belonging to the real number set, such that, so the vertical line is kind of like such that, or restricting the domain, such that t has to be less than or equal to 4/3, so the opposite of what we found here, so that we end up with only defined values. Okay, so we went through a definition of functions, a few properties of functions, we looked at the domain of functions, and that's pretty much it for this lesson. Again, this should all just be review. Our next lesson, we'll be looking at our next section, which again will be a little bit more review, but we'll start to learn new material in chapter 2.